Tesla is the most recent unconventional chip maker to create its own silicon. Other firms that are significantly involved in AI such as Google, Amazon, and Microsoft are now designing their own chips as the technology becomes increasingly crucial and costly to deploy. Hey everyone, and welcome to Tesla News, where we bring you the newest and best updates about Tesla and Elon Musk. For daily videos, please consider subscribing to our channel and turn on the notification bell to get updates on the latest news about Tesla. Don't forget to join our Discord server to discuss future topics. Let's get started. Tesla released specifics of a unique AI processor named D1 for developing the machine learning algorithm underpinning its Autopilot self-driving system at a promotional event last month. Tesla's AI development was highlighted at the event, which featured a dancing person dressed as a humanoid robot that the company plans to build. Tesla CEO Elon Musk stated during the event that getting more performance out of the computer system used to train the company's neural network will be critical to autonomous driving advances. He went on to say that training a model takes a number of days versus a couple of hours, and that this is a significant difference. After moving from NVIDIA hardware in 2019, Tesla now designs processors that interpret sensor information in its cars. However, developing the kind of powerful and complicated microprocessor required to train AI algorithms is much more expensive and difficult. If you believe that training a large neural network is the solution to autonomous driving, then what followed was exactly the kind of vertically integrated strategy you'd need, says Chris Gerdes, director of Stanford's Center for Automotive Research, who attended the Tesla event. Tesla's relying increasingly heavily on neural networks to recognize objects on the road, with a single massive neural network known as a transformer getting information from 8 cameras at once. In recent years, transformer models have made significant breakthroughs in areas such as language comprehension. The gains have come from making the models larger and more data-hungry. Cloud computing power costing several $1 million is required to train the most powerful AI models. According to David Cantor, a semiconductor analyst at Real World Technologies, Musk believes that by speeding up the training, he'll be able to propel the entire machine, the self-driving program, ahead of the Cruises and Waymos of the world, referring to 2 of Tesla's autonomous driving competitors. Tesla's plan, according to Stanford's Gerdes, is based on its neural network. Tesla, unlike many other self-driving car firms, does not use LiDAR, a more expensive type of sensor that can view the world in 3 dimensions. Instead, it interprets scenes by passing data from its cameras and radar using a neural network algorithm. Because the algorithm must reconstruct a map of its surroundings from camera feeds rather than relying on sensors that can record the picture directly, it's more computationally demanding. Tesla, on the other hand, collects more training data than other automakers. The video feeds from each of Tesla's 8 cameras are sent back to the firm by each of the company's more than 1 million vehicles on the road. Tesla claims to use 1,000 people to help train the massive transformers by labeling the images, noting automobiles, trucks, road signs, lane markings, and other objects. Tesla also announced at the August presentation that it can automatically choose which photographs to categorize first in order to speed up the process. NVIDIA, which began out creating gaming processors, presently dominates the market for AI training chips. When it became evident that its graphics processing units, GPUs, were more suited to running big neural networks than the central processing units, CPUs, at the heart of general-purpose computers, the business shifted its focus to AI chips. AI is also driving the diversification of semiconductor architectures in a nifty bit of recursion. Chip design generally necessitates a high level of technical knowledge and judgment. However, machine learning has proven to be successful in automating some aspects of the process. Chips created in part by AI are being produced by Google, Samsung, and others. According to Cantor, key technical problems about specialized chips like Tesla's D1, such as how well they can be coupled together and how well an algorithm can be broken up and dispersed across different processors, remain unanswered. The method, which is built on powerful AI for vision and planning, supported by effective use of inference hardware, is the only way to provide a general solution for full self-driving and beyond, according to Tesla Artificial Intelligence and Autopilot. Tesla's self-driving plan has been attacked as risky and outdated, with other companies abandoning it years ago. Most experts feel Tesla's strategy of avoiding high-definition maps and LiDAR in order to accomplish autonomous vehicles is unrealistic. Tesla's strategy had been attacked by auto expert Brad Templeton, who claims that the no-map technique entails forgetting what's already been learned and starting over. In a May 2021 review by Guidehouse Insights, Tesla was ranked last in the autonomous driving category for both strategy and execution. Missy Cummings of AI found significant between and within vehicle variation on a number of metrics related to driver monitoring, alerting, and safe operations of the underlying autonomy in 3 Tesla Model 3 cars in August 2021. This implied that the performance of the underlying artificial intelligence and computer vision systems was extremely variable. Tesla was found to have misled consumers about the capabilities of its automated driving systems by German regulators in July 2020, and the company was barred from using specific marketing language implying autonomous driving capabilities. When it comes to safety, the National Transportation Safety Board (NTSB) chastised Tesla for failing to implement system safeguards in a fatal Autopilot collision in California in 2018, as well as for failing to anticipate and prevent predicted Autopilot abuse. The Center for Auto Safety and Consumer Watchdog has requested federal and state investigations into Tesla's Autopilot marketing in order to give consumers the false impression that their cars are self-driving or autonomous, which they believe is dangerously deceptive and dishonest. Tesla's Autopilot, according to UK safety experts, is particularly misleading. In comparison to a similar level, 2 driver assistance systems from other automobile companies, a 2019 IIHS study found that the name Autopilot caused more drivers to misperceive behaviors like texting or napping to be safe. In a research titled Auto No Washing, the greenwashing of vehicle automation, released on Science Direct in May 2020, Tesla's Autopilot and FSD capabilities were attacked. US regulators issued an order in June 2021 requiring automakers to disclose crashes involving vehicles with ADAS technology. This ruling comes as such technologies, particularly Tesla Autopilot, have come under heightened regulatory scrutiny. Let's take a look at some of the specs used in Tesla's self-driving technology. The hardware consists of silicon chips that are designed from the ground up to power full self-driving software, taking into account every little architectural and micro-architectural enhancement, while pushing hard to squeeze maximum silicon performance per watt. It analyzes the design for floor planning, time, and power. It also creates reliable randomized tests and scoreboards to ensure that functionality and performance are met. It develops compilers and drivers for programming and connecting with chips, with a focus on speed and efficiency. The silicon chip is then validated and mass-produced. Neural network connections train deep neural networks on challenges ranging from perception to control using cutting-edge research. As raw images are analyzed, the per-camera networks execute tasks such as semantic segmentation, object detection, and monocular depth estimation. Video from all cameras is used to create a top-down representation of the road layout, static infrastructure, and 3D objects. Iteratively sourced in real time from our fleet of about 1 million vehicles, the network learns from the world's most complicated and diverse scenarios. 48 neural networks and 70,000 GPU hours are required to train the Autopilot neural network architecture. The tensors are generated in 1,000 distinct ways at each time step, predictions. They develop the key algorithms that operate the car by constructing a high-fidelity representation of the world and planning routes in that area when it comes to autonomy algorithms. Algorithmically construct accurate and large-scale ground truth data by merging input from the car's sensors across space and time in order to train neural networks to predict such representations. They employ cutting-edge methodologies to develop a powerful planning and decision-making system that can work in complex real-world scenarios while dealing with ambiguity. Evaluate your algorithms on a larger scale than the Tesla fleet. Let's have a look at the code foundations. The major measures used to optimize the code are throughput, latency, accuracy, and determinism. The underpinnings of the Autopilot software were built from the ground up, seamlessly interfacing with our unique hardware. Super reliable bootloaders were implemented, with support for over-the-air upgrades and the ability to boot customized Linux kernels. It could write memory-efficient low-level code to capture high-frequency, high-volume data from our sensors and share it with various consumer processes without affecting core memory access latency or depriving key functional code of CPU cycles. It squeezes and pipelines computation over numerous system-on-chips using a range of hardware processing units. Build open and closed-loop hardware in-the-loop assessment tools, and infrastructure at scale to speed up innovation, measure performance improvements, and avoid regressions. It utilizes the fleet's anonymized characteristic clips and incorporates them into a huge number of test scenarios. As a result, it generates highly realistic graphics and sensor data that's delivered to the Autopilot program for live debugging and automated testing. TeslaBot is working on the next generation of automation, including a bipedal humanoid robot that can undertake dangerous, monotonous, or tedious activities. It's looking for mechanical, electrical, controls, and software professionals to help it expand its AI capabilities outside of its fleet of vehicles. That brings us to the end of the video. If you found it interesting, please hit the like button and subscribe to stay updated on new videos. Please let us know what you think in the comments below. I'll be back soon with another interesting video. Until then, good luck.